Yes, hello, good afternoon. So, I'm going to discuss with you today about the last topic that we need to learn for midterms, and this is time rates on water. Okay, so I'm going to share to you the screen where I'm going to do some calculations, and here it is. Oh, I have to share the. hmm. Let me just check my sound because there's a problem with the sound a while ago.
Let me just check my
Okay, so
sound because there's a problem with the sound a while ago.
that's fine.
Let me just check my sound.
Right. Right. So here is the first question that I'm going to tackle with you. So it says here a ladder is 15 feet long, leans against a vertical wall. What is a ladder? What do you think a ladder is? A ladder is a temporary structure. Yeah. If this is a wall and here is the ladder, this is used to transport anything up the stairs or down the stairs. And there are some steps. Okay, so you use this to move up some objects or bring down some objects. And it's like a stairs, but it's temporary in nature. You can move it anywhere you want. And normally, it is leaned on a vertical surface. Normally, it stays on the ground and it's leaning on a vertical wall. Okay. Now, it says in the question that the ladder is 15 feet long. If the top slides at a rate of 2 feet per second, yeah, so the top slides down at 2 feet per second. What happens to the ladder after? Then it becomes like this after some time, correct? Because it's sliding down. Or it can be like that after some time. Now, we're going to get the change of the slope. If this is the angle, then if it changes to a smaller one, theta 1, theta 2, theta 3, so we have to get the change at which the bottom of the stairs would be moving from one point to the other after some time. So if we may draw another one here, how fast would this ladder be moving from A to B position when it is 10 feet from the wall? Okay, so assuming that we're going to analyze at point B, 10 feet from the wall. Okay, For ladder questions, we will be using Pythagoras theorem. What does it say? Pythagoras theorem, this is applied to right angle triangles where the sloping side is your C. One of the sides could be an A or a B. If your angle is C, we're going to assign C for this corner where the right or where the square corner is. Sorry, that should be C. And C, and the adjacent side I should say is A. So the opposite angle should be also A. This is the angle. And the other angle is B. Opposite side is B. Okay. This is the corner C, and the side C will be on the other side, which is the hypotenuse. It says in the Pythagoras theorem that the square of the hypotenuse is the sum of the squares of the other sides. Okay? Now, from our question here, our hypotenuse is 15 feet. Let's call this one as our x and the other side as y. From our illustration a while back, x is actually our A and y is our B. Our C is 15, we're going to square that, equal to our A is x, so x squared, and our B is y, so y squared. It seems that y is the one missing because we know what x is, that's 10, y, that is what we do not know, based from the size of our right triangle form. We move our 10 squared to the other side, so 15 squared minus 10 squared is equal to y squared. 15 squared is, let's do some calculations here manually. 5 times 5 is 25, you put 2 there. 5 times 1 is 5 plus 2 is 7. 1 times 5 is 5. 1 times 1 is 1. So 5, 12, 225, okay? So that's 225, take away 100, 10 times 10 is 100, is equal to y squared. 225 minus 100 is 125, equal to y squared. And then to get just y, you have to extract the square root on both sides. Let me just rub this off so we will have a cleaner place to write our workings. Then the square root of y squared is just y, and square root of 125 is, if we may take it from the calculator, that will be 125, and square root of that is 11.180. So we have 11 point, that's too thin, 11.180 feet, okay, or y is 11.180 feet. If you can see notations like 11.180 and there is like a little line up there, this is feet as well. That's just a symbol, okay? So knowing 11 point, why did I do that? There. Knowing y to be 11.180, we are now ready to do the derivative of the equation we just have established a while ago. So let's go back there. 15 squared is equal to x squared plus y squared. I think we need a thicker, we need a thicker, we need a thicker pen. So that's 15 squared equal to x squared plus y squared. The derivative of a constant is 0. The derivative of x squared with respect to time is 2x dx over dt. The derivative of y squared with respect to time will be 2y dy over dt. In case x is a cube and you want to get the derivative of x cubed with respect to time, then this will be 3x squared dx over a. But because it's a square, x squared, so it's just 2x dx over dt. Let's continue. Okay. So now we can move our 2y dy over dt on the other side, which will be a negative 2y dy over dt is equal to 2x dx over dt. Because there are 2 on both sides of the equation, then you can cancel them out. If not, you can just divide both sides by -2. That cancels out, and the 2 cancels out as well. 2 divided by -2 is a -1, or negative 1x, or simply x dx over dt. But you have still a y on the side, dy over dt. What we are interested in is what is the rate of the ladder going down the vertical wall. So that is our dy over dt. Now let's divide both by y. The y cancels out. Then you have dy over dt, which is the unknown, is equal to negative x over y dx over dt. Let's go back to our figure a while ago. What is our x? It's 10 feet. What is our dy over dt? It's 2 feet per second. What is our dx over dt? Hey, it's not the dy over dt that is unknown. It's the dx. All right. So, and our y is 11.180. Nonetheless, what is unknown here? Our unknown is the dx over dt, sorry for that. So dy over dt is 2 feet per second, okay? And then dx over dt is what we're trying to find. Our x is 10 feet, and our y is 11.180 feet. Let's substitute all of these values. dy over dt is -2, equal to x is negative 10 over 11.180 dx over dt. Okay, it doesn't matter if we exchange them. So let's just simplify this one. Negative 10 divided by 11.180 is equal to 0.8945. So this is negative 0.8945 dx over dt. This is -2 on the other side. To get for dx over dt, you just have to divide it by 0.8945 divided by -8945. So you have dx over dt is equal to 2 divided by 0.8945. Let's do it. 2 divided by 0.8945 gives us 2.236. 2.236 feet per second. That's how fast, what does it mean? That's how fast the bottom of the ladder is moving away from the wall. And this is the answer of the first question. So this is what we are looking for. How fast is our ladder moving away from the wall? Okay, there you go. Next question. For the next question, I already had done it a while ago. So a ladder is leaning against a wall, a vertical wall. The ladder is 10 meters long, and the bottom of the ladder is sliding from the wall at a rate of 2 meters per second. Look at this one. It is moving away from the wall. It's moving away from the wall. Okay, at a rate of 2 meters per second. How fast is the top? So it's the same as the first one. How fast is the top of the ladder descending down the wall when the bottom is 6 meters? Okay, so it's the same approach. We have to get the unknowns in our right triangle. So we have c squared is equal to a squared plus b squared. Our c squared here is the length of the ladder, so 10 square, 10 meters square. A, which is the bottom bit, is 6. And y is the unknown again. Okay, we have the same pattern all the time in ladder questions. So 10 square, we have to move the c squared to the other side, which makes it negative. 10 square minus 6 square is equal to y square. And 10 square is 100, minus 6 square is 36. So that will be 64, but because we like to get the value of y, we have to square root both sides. And the square root of 64 is 8. Thereby, y is 8 meters for this example. And then we go back to the equation a while ago where we have 10 square is equal to x squared plus y squared. The derivative of 10 squared is 0. The derivative of x squared is 2x dx over dt. The derivative of y squared is 2y dy over dt. Let's move our dy over dt to the other side. Doing so will give you a negative sign, negative 2y dy over dt. And 2x dy, hang on, before that, let me just do it again because there are already a lot of slashes here. So let's move 2y dy over dt to the other side. That makes 2y negative dy over dt equal to 2x dx over dt. Okay? We can divide both sides by negative 2y over negative 2y, or negative 2 first if you want. Okay, but I divided both by negative 2y, so we can slash 2y straight away. And we can also slash 2 and 2 here, which will give you a minus x over y. Okay? And dx over dt. Okay? X over y, here you go. X over y, which is negative, dx over dt. Now, if you're going to ask me, is negative x over y equal to x over negative y is equal to negative x over y? Yes, the answer is yes. Because if you're going to divide them, you will always get a negative answer because one is negative. Okay, negative divided by positive is negative. Positive divided by negative is negative. Negative divided by both positive is also negative. So the quotient will always be a negative. So dy over dx, dy over dt is equal to negative xy dy over dt. So let's substitute now. Where is my negative here? The negative wasn't written. So let's put the negative aside there. So our x is 6, our 8 is our y, and 2 is dx over dt. So 6 times 2, why did I do that? Because 2 has 1 as a denominator. 6 times 2 is 12, and 8 will be the denominator. You divide both the numerator and denominator by 4. 12 divided by 4 will give you 3, and 8 divided by 4 will give you 2. So the answer here is 3 halves. Okay? The answer here is 3 halves, and that is negative. Or is a negative 1.5 meter per second. Why is it negative? Because dy over dt is going down. That's why you have a negative 1.5 meter per second as the rate at which your top part of the ladder is moving down the vertical wall. Okay? Now, let's check our answer of the previous example. Why is it positive? Because, look, this is the ladder. The ladder is moving to the right. More often, to the right is positive. If it goes left, it's negative. When it goes down, it's negative. When it goes up, it's positive. Where can we get all of these signs? In our Cartesian coordinate system, this is a positive x. Going to the left is a negative x. Going up is our positive y. And going down is our negative y. Okay? So those are the directions. Now, what is your work pertaining to this example? This will be checked or marked after the midterm exam. So homework is the one up there, but I'm going to flash it later. To be marked after, I repeat, to be marked after the midterm exam. You have to write it in your notebook. Okay? And what is the homework? This is the question. A ladder 12 meters long is resting against a vertical wall. The bottom of the ladder is being pulled away from the wall at a rate of 4 meters per minute. How fast is the angle between the ladder and the ground changing when the bottom of the ladder is 9 meters away from the wall? To help you out, the 12 meters, that is the length of the ladder, and the bottom of the ladder is being pulled away. The 4 meters per minute is dx over dt. So this is per minute. This is similar to my example number 1. Now the bottom of the ladder is 9 meters away. So it means the vertical or y is unknown. So get the y first, and then you have to get how fast is the angle between the ladder and the ground changing when the bottom of the ladder is 9 meters away. So you have to use, or you have to get the dy over dt for this one, okay? Just to make the solution simple, you have to get the unknown will be dy over dt. Why? Because the 4 meters per minute, this one, is your dx over dt. All right, so this will be your homework. Don't forget, I repeat, this will be marked after the midterm from your notebook, okay? All right, see you then, and prepare for your exam, okay? Bye. Your booklets, please. Don't write on the first few pages. All your clues, your guides, whatnot, will be at the back, from the back, at the back of your booklet. Bye for now.